Welcome to the DIY Honda Garage channel. The diagnostic trouble code DTC P0840-17 indicates an issue with the continuous variable transmission CVT driven pulley pressure sensor circuit being high. This sensor plays a critical role in monitoring the pressure within the CVT, which affects the transmission's ability to operate efficiently. The Transmission Control Module, TCM, relies on this data to make real-time adjustments for optimal performance. If the output voltage from this sensor exceeds a specified threshold, the TCM flags the problem and the DTC is stored in the vehicle system. Understanding this code is essential for effective troubleshooting of the transmission system, ensuring reliable vehicle operation. This slide serves as an overview of the error and its implications in the Honda CR-V 2023 and newer models, setting the stage for our detailed analysis and troubleshooting steps. The CVT-driven pulley pressure sensor is integral to the Honda CR-V's transmission system. Positioned within the transmission assembly, this sensor measures the hydraulic pressure, which is crucial for the CVT's operation. The TCM uses this information to determine how to shift the CVT effectively, thereby optimizing engine performance and fuel efficiency. When the voltage from the sensor is higher than 4.84 volts, this indicates a potential fault, triggering the DTC P0840-17. The TCM, or Transmission Control Module, is responsible for processing data from various sensors, including the CVT-driven pulley pressure sensor, and it can signal the presence of an anomaly when incorrect data is detected. This detail is crucial for technicians who must understand the interconnected nature of these components to accurately diagnose the issue at hand. Several factors can lead to the occurrences of DTC P0840-17. First, a faulty CVT-driven pulley pressure sensor may produce inaccurate voltage readings, resulting in a higher than normal output, thereby triggering the error code. Second, wiring issues such as open circuits can interrupt the communication between the sensor and the TCM, leading the latter to register an abnormal reading. Third, a malfunctioning TCM itself could misinterpret the sensor data or fail to process it correctly. Each of these causes significantly affects the CVT's effectiveness, and pinpointing the exact issue is necessary for proper repair. A thorough understanding of the components involved and their functions helps technicians quickly identify and resolve these problems. Drivers may experience a variety of symptoms reflective of DTC P0840-17. Commonly reported issues include noticeable transmission performance problems, such as a lack of power during acceleration or hesitation while shifting. These performance issues are often tied directly to erroneous sensor readings affecting the CVT's operation. Erratic shifting patterns may also be observed, where the vehicle fails to shift smoothly between gears or shifts unexpectedly, contributing to a subpar driving experience. Lastly, the illumination of the check engine light serves as a visual cue to the driver that there is an underlying issue needing attention. Recognizing these symptoms is essential for drivers to seek timely repair, thus preventing further damage to the vehicle. The first troubleshooting step is to turn the vehicle to the on mode to prepare for diagnostics. It is critical to note that the Honda Diagnostic System, HDS, is employed here to retrieve sensor data, specifically looking for the driven pulley pressure sensor voltage output. If this voltage reading exceeds 4.84 volts, this confirms the duplication of the failure that the DTC indicates. This initial check is foundational because it establishes whether the sensor is indeed outputting abnormal levels, validating the need for further investigation. If the reading remains normal, the troubleshooting can be directed to the other potential causes instead, avoiding unnecessary component replacement and focusing efforts where they are truly needed. In this second step, the technician disconnects the CVT-driven pulley pressure sensor connector to conduct further inspection. This disconnection is imperative for testing the sensor's output voltage when it is not affected by other components. The expected voltage should be around 5 volts when the ignition IG mode is activated. This measurement helps determine whether the sensor itself is operating correctly. If the output voltage is as expected, it indicates the sensor is functioning properly, leading the technician to investigate other components in the circuit for potential issues. Conversely, if the voltage is incorrect, it suggests that the CVT-driven pulley pressure sensor may be faulty and in need of replacement, demonstrating how this step is critical in isolating the issue. This third step involves disconnecting the transmission control module, TCM, connector from the vehicle's system. It is a necessary step to evaluate the circuit integrity. The next task is to check for open wiring in the circuit linked to the CVT-driven pulley pressure sensor. This includes testing the voltage supply circuit, the ground circuit, and the signal circuit. Each should indicate less than 1 ohm resistance when measured under the correct conditions. If any of these circuits are found to have abnormal resistance or display an open connection, it becomes the source of the DTC. This step is critical for ensuring that all connections and circuits are functioning properly, establishing a clear path for communication between the sensor and the TCM. The final troubleshooting step focuses on the TCM itself. After confirming all other components and circuits are in normal working order, the TCM becomes the last suspect for the DTC. If the previous checks have indicated normal operations, the TCM likely has an internal failure or is unable to process the sensor data correctly. Inspection methods may include specific diagnostic tools that assess the TCM's functionality to ensure it is reading the input signals appropriately. A proper understanding of the TCM's role in interpreting sensor data is vital, as this module governs the operational parameters of the CVT. If the TCM is found faulty, it will require replacement or reprogramming to restore the vehicle's normal transmission operations. Following the completion of repairs, it's essential to verify the effectiveness of the solution. Initially, technicians should recheck the output voltage of the CVT-driven pulley pressure sensor to confirm that it is within the expected range, ideally around 5V. If this voltage now reads correctly, it supports that the initial issue has been resolved. Next, clearing the diagnostic trouble codes, DTCs, from the vehicle system is necessary before conducting a test drive. The test drive allows observation of the vehicle's response under real-world conditions, ensuring that the CVT operates smoothly and the check engine light remains off. Successful completion of this verification process is what ensures long-term reliability and performance post-repair. To prevent future issues related to DTC P0840-17, regular preventive maintenance is critical. One of the most effective steps to take is conducting periodic checks of the transmission system, focusing specifically on the CVT and its components. These checks allow for early detection of potential issues before they escalate into more significant problems. Additionally, monitoring the condition of the transmission fluid is vital. Maintaining the proper fluid levels and ensuring that the fluid remains clean is essential for efficient operation. Fluid changes should align with the manufacturer's recommendations to prolong the lifespan of the components involved. Proactive maintenance is essential for any vehicle, particularly complex systems like a CVT, which rely heavily on sensor data for optimal performance. In conclusion, diagnosing and resolving DTC P0840-17 involves a systematic approach that highlights the importance of understanding the roles of various components, such as the CVT-driven pulley pressure sensor and the TCM. Each step in the troubleshooting process is designed to isolate the problem, from initial diagnostics to thorough inspections of wiring and circuit integrity. By carefully adhering to the outlined troubleshooting steps, technicians can efficiently identify the root cause of the issue and take corrective action accordingly. Moreover, the importance of preventive maintenance cannot be overstated. Regular checks and fluid monitoring can mitigate the risk of recurrence. Ultimately, a comprehensive understanding of both the problem and preventative strategies enhances vehicle reliability and performance. Please like and subscribe to the channel. See you next time.